Hello everyone, once again welcome to PM Networking. Guys, today in this video we are going to understand basic and advanced redistribution of EIGRP. Because when students get enrolled for paid course, what I have seen is that people know the configuration but they have problem in traffic flow. Most of the network engineer don't know traffic flow, but this is very important because nowadays configuration is not important because we have SD-WAN, we have Python, we have a script, right? So configuration is not important and people know configuration, but people don't know traffic flow. So this video will guide you to understand traffic flow of EIGRP. So if you are a network engineer, make sure you will watch the video till the end. Definitely if you are thinking that I already know the redistribution of EIGRP, no guys, I am damn sure if you will watch this video till the end, you will learn something new that you don't know. Okay, so without wasting our time, let's begin. First of all, let me make you familiar with this topology and then I will start configuration. Okay, so see, in the topology I have three routing domain. This is my EIGRP domain, this is my RIP domain, and this is my OSPF domain. You can consider that this is a network of an big organization, and in that organization there are three departments, right? Department 1, department 2, and department 3. Let me make you understand how this scenario can be implemented in real time. Okay, so suppose in an organization there are three departments. All departments are very large, right? Suppose this is HR and manager department, where network engineer is working and they are good in EIGRP, so that's why they are running EIGRP in that domain. So this is suppose a domain of manager and HR. Okay, and network engineer of this domain is good with EIGRP, so that's why he is configuring EIGRP over here. Okay, suppose this is department 2, suppose this is sales department, right? Here also there are lots of user, right? There are suppose 10,000 user in sales department in the different location, and the network engineer who is working in this department is good in RIP, so that's why he is using RIP routing protocol to exchange routing table between routers. Okay, suppose this is another department, let's say marketing department, right? And the network engineer who is working in marketing department is good in OSPF, so that's why he is using what? OSPF. And suppose you are the super network engineer of this organization, so your responsibility is to make communication possible between all domain. Yes or no? Because EIGRP prefixes, suppose here we have 500 prefixes in EIGRP domain. So router 3 will have 500 prefixes, route for all 500 prefixes, but RIP domain router means router 4, router 5 does not have these prefixes. Yes or no? Because EIGRP update message will be travel in EIGRP domain only. Yes or no? And RIP update message will be travel in RIP domain only. In the same way, OSPF update message will be travel in OSPF domain only. So OSPF prefixes will never come in EIGRP domain or in RIP domain. Yes or no? In the same way, RIP domain prefixes will never come in EIGRP domain or in OSPF domain. And in the same way, EIGRP prefixes of EIGRP domain will not enter in RIP domain and not enter in OSPF domain. So that means these user from this network will not communicate with user of this network. In the same way, user of this network as well, right? So if you want to make communication between all the user, between all routing domain, what you need to do here? You need to perform redistribution on router number 3. Yes or no? You need to perform redistribution, guys. So first of all, we are going to understand basic redistribution on router 3. See what I need to do over here. In the EIGRP domain, in this domain, I need to inject all prefixes of RIP here, right? That means I need to redistribute RIP prefixes in RIP in EIGRP. Yes or no? So after redistributing RIP prefixes in EIGRP, these all prefixes will enter in EIGRP domain. Yes or no? Then you need to Inject all EIGRP prefixes in RIP domain. Yes or no? So you will redistribute EIGRP into RIP. So RIP router number 5, router number 4 will also receive these all prefixes. Done. After that, you have to redistribute OSPF prefixes in EIGRP, right? And EIGRP prefixes in OSPF. Yes or no? So this will be the redistribution. You need to perform how many redistribution, guys? 3 redistribution. Yes, one RIP into EIGRP, another one EIGRP into RIP, another one OSPF into RIP, and OSPF into EIGRP, and EIGRP into OSPF. So 4. Again we need to perform one more redistribution, actually 2 more redistribution, right? OSPF prefixes in RIP domain and RIP prefixes in OSPF domain. So actually total number of redistribution that you need to configure over here is 8. Yes or no? 8. One is first EIGRP into RIP, second RIP into EIGRP, third EIGRP into OSPF, fourth OSPF into EIGRP, right? After that RIP into OSPF and OSPF into RIP. So total number of redistribution will be not 8, 6. Okay, so let's understand how we will configure it. First I am going to show you basic redistribution. So on router number 1, if you will check routing table, so IP root, so you can see there are lots of prefixes in the routing table of router 3. Yes or no? So I need to filter the output. Just let me check the EIGRP prefixes. So IP root EIGRP. So this command will show you all prefixes of EIGRP domain. So here you can see this router is receiving all 10 prefixes. Yes. Now so IP root RIP. This command will show me the all prefixes of RIP domain. So it is showing me all 50 network. Yes or no? And so IP root OSPF. This command will show me all prefixes of OSPF. Yes. Now on router number 1, if you will check routing table, so IP root EIGRP. See, router 1 is not receiving any RIP prefixes. Router 1 is not receiving any OSPF prefixes. Yes or no? So now if I will ping 50.1.1.1 and source is, let's say 10.1.1.1, it will not work because router 1 does not have root. So now first of all I am going to redistribute RIP prefixes in EIGRP. So here how you will do it? Router EIGRP, I am running AS number 10 over here. So 10 and redistribute RIP. Guys, if you will hit enter over here, so it will see, let me hit enter. I have entered. I have run redistribute RIP. So router 1 will not receive any RIP prefixes. Yes or no? See. Yes, still router is not able to ping because metric calculation of RIP is different. Metric calculation in RIP is hop count and metric calculation in EIGRP is different. So here you have to define metric components as well. Yes or no? Then only you can redistribute RIP prefixes in EIGRP because EIGRP uses k value to calculate metric. So you have to define k value. So let me remove this command from router number 1. Say no. After that, redistribute RIP and then metric. So what will be the value of K1? So let's say K1 is 10 raised to power 5. After that, delay. So delay will be, let's say 100. After that, reliability, let's say 100% reliable, 255. Then load, let's say 100. And MTU, let's say 1500 byte. Now it will start redistributing RIP prefixes in EIGRP because this time you have tail to router number 3 that use these metric components. Yes or no? To calculate metric. So now if you will check routing table of router 1 over here, you can see, right? Router is receiving all external prefixes, right? All these are prefixes of RIP. Done, guys. But still router 1 cannot ping 50.1.1.1. Why? Because now router 5 does not have a reverse path. So see, on router number 5, actually router 5 is receiving ICMP request, but router 5, how router 5 can generate it reply? So IP root, because here 10.1.1.1 prefix is not available. So IP root rip. See, right here, if you will enable debugging, debug IP ICMP, and let me ping again. Ping. So see now, it is receiving ICMP traffic, yes or no? Router number 5, but router 5 does not have root to generate reply. So what I need to do? I need to redistribute EIGRP into RIP. Okay, let me do that also. Router RIP and redistribute EIGRP, and here metric EIGRP S number 10 and then metric. So metric in RIP is hop count. So here you will define hop count. Let me define 5. So it will advertise, it will redistribute EIGRP prefixes in RIP domain with metric 5. So router number 3 will redistribute with metric 5. Router 4 will share the prefixes to router 5 with metric 6. So here metric will become what? 6, guys. Done. So let me do it over here. And now on router number 5, if you will check routing table, where is router number 5? Here it is. Let me disable debugging, say on all, and so IP root rip. Now you can see router is receiving all EIGRP prefixes with what metric? With metric 6, because on router number 3 you have defined metric 5. And now if router 1 will ping, it will work. You can see it's working. Yes or no? In the same way, router 1 is not receiving OSPF prefixes. So IP root EIGRP. So router 5 is not receiving any 70 prefixes. Yes or no? So what I need to do? I need to redistribute OSPF into EIGRP as well. So again, let me take you on router number 3 and router EIGRP S number 10 and redistribute OSPF process ID 1 and then metric. So here again you need to define what? Metric. So let's say K1 is this one, 100, 100, 100 and 1500 byte MTU. Done. Now on router number 1 you can see the routing table of router 1. It will receive 70 prefixes as well. So are you able to see? Yes, you are able to see, guys. Yes or no? So these are actually prefixes of RIP and these are prefixes of OSPF. Yes or no? So how you will identify that these are RIP prefixes and these are OSPF prefixes? So till now we are not able to see any information who will identify that these are prefixes of RIP and these are prefixes of OSPF, because I am able to see only external prefixes. So these are external prefixes, and as you know, EIGRP uses 170 AD value for external prefixes. So you can see AD value for all external prefixes is 170. Done, guys? So here I have one problem. Whenever I need to redistribute the other domain prefixes in EIGRP, I need to define K values every time. Yes or no? So this is complicated task. So let me remove the all redistribution configuration from router number 3. So I have say no redistribute OSPF prefixes in EIGRP. After that, router EIGRP S number 10, say no redistribute RIP, no redistribute RIP and K values as well. Let me define K values over here as well. Say no. How I can find the redistribution command? Do so run pipe section EIGRP. Okay, so I need to remove which entry? Only this entry is available there. Okay, so let me remove router RIP and say no, and let me remove this command as well. Okay, now router 1 is not receiving any external prefixes again. You can see. Done, guys? Okay, now this time what I am going to do, I am going to define the K values on router number 3 on default K values, right? And whenever we will perform redistribution of any routing domain prefixes in EIGRP, we don't need to define what? K values again and again. So see here what I will do, say router EIGRP yes number 10, and default metric. So here I am going to define one default metric. So K1 will be 1, 2, 3, 4, 5. Every time whenever I will redistribute any other routing domain prefixes in EIGRP, it will use this value as K1. I will not define K values at the time of redistribution. So K1 will be this one. After that, delay will be what? Delay will be 10. Then reliability will be 255, 100% reliable. Load will be also 255, and MTU will be 1500 byte. Now guys, now I need to redistribute what? RIP in EIGRP. So I need to run only command redistribute RIP. Earlier this command was not working, right? But now it will work because I have already defined metric K1, K2, K3, K4, K5. So on router number 1 you can check it. See, router have started receiving all RIP prefixes. Now here I can run directly command redistribute OSPF process ID 1 as well. So router 1 will receive all prefixes of OSPF as well. See, so this is actual way how in real time we perform redistribution. You will define a default K values on your edge router. What do you mean by edge router? Edge router means router who is connecting multiple routing domain together. Yes or no? So that type of router is edge router. So here router number 3 is my edge router. Yes or no? Okay. So this is basic redistribution. If I will ping 10 dot ping 50.1.1.1 and source is 10.1.1.1, it will not work because I need to redistribute what? EIGRP into RIP, EIGRP into OSPF. Yes, so let me take you on router number 3 again and say router RIP and redistribute EIGRP S number 10 and metric is, let's say, 5. Okay, after that redistribute, sorry, not here, router OSPF process ID 1, I am running process 1. So redistribute EIGRP S number 10. And guys, if you will run this command, so OSPF by default will redistribute only class full network. Okay, so here you need to add one keyword, that is subnet. This will enable classless routes, classless prefixes redistribution. If you will not define subnets over here, OSPF will redistribute only class full prefix. But in EIGRP domain, I have lots of classless prefix. Yes or no? Okay, and you don't need to define metric over here because OSPF have capability to calculate metric by their self. So let me hit enter over here. It will redistribute all EIGRP prefixes in OSPF. Now on router number 1, if you will verify, so IP root, you can see this router have all prefixes of RIP, all prefixes of OSPF. If I want to ping 50.1.1.1 from here, from my LAN interface, so see, I am able to ping. If I want to ping 70.1.1.1, 70.1.1.1 and source is 10.1.1.1, yes, I am able to ping. That means router 7 have also prefixes of EIGRP and router 1 have also prefixes of EIGRP. But now router 5 and router 7 cannot communicate with each other because RIP and OSPF redistribution is still pending. So if you want to make communication possible between these two domains, so here you need to redistribute OSPF prefixes in RIP and RIP prefixes in OSPF also. Not I am going to redistribute this over here. In OSPF advanced redistribution, we will understand what is the redistribution behavior of OSPF. Now we are discussing only EIGRP redistribution. Okay guys, now my concern is here on router number 1. See, so IP root, I am able to identify external prefixes and internal prefixes, but I am not able to identify the RIP prefixes and OSPF prefixes over here. I am not able to identify which prefixes are of sales department and which prefixes are of marketing department. Yes or no? So what I need to do over here, I need to identify. So what I can do, I can run so IP EIGRP topology. So IP EIGRP topology. Here also I am not able to see any information about external protocol. Yes or no? So let's say 50 network. You can see 50 is external, but here I am not able to see any information who will tell me that this is a root, this is a network of RIP domain. So command to check the external source protocol is so IP EIGRP topology, and then you have to define network ID and subnet mask. That means you are checking the topology table of a network in detail. So 50.1.1.0 subnet mask 255.255.255.0. So by running this command, you can see over here. Here you can check the external protocol is RIP. Yes or no? But is it possible, guys, to run this command for each network to identify that which network is from RIP and which network is from OSPF? It's not possible, because suppose here in the RIP domain there are 500 prefixes. There are 500 prefixes over here and 500 prefixes over here. So if you want to check all these 500 prefixes on router number 1 belongs to which routing domain, you have to run 500 command. Yes or no? So it is not possible. Then what is solution? Solution is, while redistribution over here, you will add one tag, right? Suppose when I am redistributing RIP in EIGRP, I will add one tag number, let's say 10. So here if you will see the prefixes with tag number 10, then you can identify that it is a prefix of sales department or of EIGRP. Okay, yes or no? Oh yes. So to add tag, what we need to do, we need to create one route map over here. Through route map you can set what? One tag. So on router number 3, what I will do, I will create one route map, and then name of route map is anything, let's say RIP underscore tag. Okay, so in real time also you will create with this type of name of route map, right? So that's why I am creating RIP underscore tag. That means I am adding tag for redistribution of RIP in EIGRP. So that's why I am defining this name, and then permit. And here you can define sequence number as well, and you can leave it as well. If you will leave it, it will use sequence number what? 10 by default. And if you will not match anything over here, it will match what? All. So I am not matching anything, so it will match all prefixes. So here I will run set tag 10. And while redistribution, I will call this route map, right? RIP underscore tag route map. Okay, so let me show you practically what I am trying to say. On router number 3, first of all, let me remove the redistribution, guys. Here say no. Okay, this is EIGRP redistribution in OSPF, so I am not going to remove this one. I am going to remove router EIGRPS number 10. Say no redistribute RIP. I have removed the RIP redistribution. No redistribution OSPF process ID 1. Yes, I have removed both. So again router 3, you can check the routing table of router 3. So IP root. Now router does not have any prefixes of RIP or EIGRP. Okay. So this time again I am going to perform redistribution on router number 3. But this time while redistribution I will add one tag. Suppose I am adding tag 10 for RIP and 20 for OSPF. So whatever prefixes you will see over here with tag number 10, that means that prefixes belongs to RIP domain, and whatever prefixes you will get over here with tag number 20, so that is prefixes of OSPF. Okay guys, if anyone wants to learn these things in detail, what you can do, you can register yourself for my live training, right? There actually we will take 2 to 3 sessions for redistribution only. Okay, so actually 5 to 6 hours we will discuss redistribution, where you will learn route map in detail, right? How route map work. So no problem, if you are getting my point, no problem, you can watch this video as well. This video is also sufficient. But if you are not able to get my point, you are not able to getting what I am explaining, then definitely you need to enroll yourself for live training. Okay, so here I am going to create one route map first. Route map name is rip underscore tag. After that, here you can see permit, yes or no. So let's say permit. I have not defined any sequence number, so it will take sequence number 10. I am not going to match anything over here. So as you already know, if you will not match, what will happen? It will match all. I am going to set tag 10. Done. So I have created one route map over here. I am going to create one more route map. Route map, and name of route map is OSPF tag. Done. And say permit. And here I am going to set tag 20. Okay. Now if you will check route map, do so route map, you can see I have created two route map. Name of this route map is OSPF tag, OSPF underscore tag, and here sequence number is 10 and it has match all and tag number is 20. Route map rip, sequence number is 10, and here I have add tag number what? 10. So with same sequence number I have created how many route map? Two route map, yes or no? And while redistribution I will call these two route map, right? When I will redistribute RIP in EIGRP, that time I will call this route map. When I will redistribute OSPF in EIGRP, I will call this route map. Done, guys? So see what I am trying to say. Router EIGRP as number 10, say redistribute RIP and route map. Name of route map is RIP underscore tag. Done. Now on router number 1, if you will check routing table, so IP root. So see, it is receiving prefixes of RIP domain or not? Yes, it is receiving. But here are you able to see any information through that you can identify that these prefixes of RIP? No. But when you will check topology table, so IP EIGRP topology, you can see the tag number. Tag is 10. Here also tag is 10. Now I want to check the external prefixes which is coming from RIP. What command I need to run? So IP EIGRP topology, and I can filter the output. Include tag is 10. So it will show me only the prefixes, external prefixes which is coming from where? From RIP domain. Yes or no? And now OSPF prefixes, router 1 is not getting any OSPF prefixes. So let me redistribute OSPF prefixes as well. So again, let me take you on router number 3 and say I am in router EIGRP 10. So see, redistribute OSPF process ID 1, and again I am calling route map, and this time which route map? OSPF underscore tag. Done. Now on router number 1, you can see. So IP EIGRP topology. Here you can see tag number is 20. That means this network is coming from OSPF domain. Here tag number is what? 10. That means this network is coming from RIP domain. Yes or no? And now if you want to filter the output, because it is very complicated here also to check, right? So if you want to check the actual source protocol of external prefixes, you will run command like this in real time. So IP EIGRP topology include, and here you will say tag is 10. It will show you all prefixes of RIP domain. Here if you will say tag is 20, it will show you all prefixes of OSPF domain. These all prefixes are external prefixes, but now I am able to see that also, that which prefixes is coming from OSPF domain, which prefixes is coming from RIP domain. Suppose we have another routing protocol like BGP, so we can do the same thing, right? Guys, you know, use of route map is a lot, right? Actually, I am providing 10-day training on route map only. So actually this is the single use of route map. Yes or no? In BGP there are lots of use. So multiple times we will use route map. Here just I am using route map to add tag number. That's it. Done. Now, so this is advanced redistribution. Now you can see I am able to identify the all external prefixes on router number 1, all external prefixes which is coming from EIGR, from RIP, all external prefixes which is coming from OSPF as well. Right? Now guys, let me remove it. Say no over here and say no over here as well. Tag number RIP, say no. I have removed the redistribution. Let's see. Now guys, see, suppose in sales department, means in RIP domain, we have two team. We have team 1 and team 2. Suppose these three prefixes are of, team A, and these are team B. So what we can do, now we can add multiple tag as well in the same route map. Okay, I can add multiple tag, because here now on router number 1, first of all I have to identify the RIP prefixes, then I have to identify the prefixes of team A as well, team B as well, yes or no? So this time I need to add what? Multiple tagging. I have to add multiple tag. So suppose for these prefixes I will tag 100, 10 is tag number of RIP, and here I am adding what? 101, let's say. And for team B I am adding 102. So this first two number is identifying what? It is my RIP prefix. So both are RIP. And last number is suppose identifying what? This is team A, this is team B. Are you getting my point, guys? These are real-time scenario only. Okay, just I am giving you example. For example, you can use any number. Suppose I will define tag number 101 for team A, and you can identify that these two number will specify the RIP domain and last number will specify the team. Okay, so let me show you this also. For that, what you need to do, first of all, you need to define interesting traffic. So if you want to add tag number 2 for these three prefixes, for these three subnetwork, what you need to do, you need to find one summary address. So what will be the summary address of this network? Summary will be 50.1.0.0/21. Yes or no? And what will be the summary address of these two network? 50.1.4.0/21.22. Let me check, guys, what will be the summary address. Here also value will be same, 121. Yes or no? So let me create some, let me create some ACL over here on router number 3. Or what you can do here, let me make some changes over here. Suppose I have some mode loopback over here, 50.1.6.0, 50.1.7.0 also, right? And these three are team A and these are team B, let's say. Okay, so let me make ACL on router number 3. Okay, so routing is fine. Sorry, recording is in process. First of all, here I am going to create what? No route map. First of all, let me remove the route map. And name was RIP underscore tag, and one more route map is there, that is OSPF underscore tag. Done. And do so route map. Now you can see there is no any route map. First of all, here I am going to create one access list. Say number is, let's say 1, permit, and summary address will be 50.1.1.0.0.0.3.255 will be the wildcard mask. Yes, and access list number 2 permit 50.1.0.0.0 4.0, 0.0.3.255. Done. I have created two access control list. Okay, so this is my interesting traffic, this is my also interesting traffic. Now in route map I will call this ACL, right? This time I will match. Earlier I was not defining any match entry, so it was matching all, yes or no. Now I am going to create route map. Name is again rip underscore tag, and here I have not defined sequence number, so it will take what sequence number, guys? 10. Or I can define sequence number as well, so let's say no over here, because I need to define permit statement as well. Route map route underscore tag, and let's say permit, and sequence number is, let's say, 10. And this time I am going to say match IP address from list number 1. So it will match IP address from list 1, and in list I have defined this network, yes or no, summary network. Okay, so I am going to say match this one, and here I am going to say set tag number 101. So route map will tag number 101, right? And it will match address from list number 1, and in list number 1 you can see the network. Done. Now with this, with the help of route map, I am going to tag 102 for team B. So again route map name will be same, rip underscore tag, and permit, let's say sequence number is what, 20. And this time I am going to say match IP address from list number 2, and set tag 102 over here. Done. Now I am going to redistribute router EIGRP S number 10, and redistribute rip route map, and name of route map is rip underscore tag. Okay, now you will check the routing table of router 1. First of all, let me check that router 1 is receiving the rip prefixes or not. So IP route, yes, you can see, yes or no. So IP EIGRP topology, here you are able to see the tag number 101. That means this 2 number is identifying that 10, that means this is prefix of rip, and last one is representing that this prefix is of team A, yes or no. This is getting individual prefix. If I want to check the network of rip domain which is coming from rip and network of team A, so what command I need to run? Router, sorry, so IP EIGRP topology, and say include, and tag is 101. So these prefixes are prefixes of team A of rip, right? Tag 102. So you can see these are prefixes of rip of team B. In the same way we can do for OSPF as well, yes or no. Suppose here also I want to perform, suppose this is my another department, this is my another department, so I want to add different tag. So here what I will add, tag number 201, tag number 202. 201 is OSPF team A, 202 is OSPF team B. So let me do same thing over here on router number 3. Let me create route map. Name is OSPF tag. Done. And before creating route map, I need to create what? Access list. So say access list, let's say number is 3, and permit 70.1.0.0 0.0.3.255 access list 4 permit 70.1.5 4.0.0.3.255. Route map OSPF underscore tag, sorry, OSPF underscore tag and permit. Done. Then match IP address from list 3 and set tag what? Set tag number 201. Route map OSPF underscore tag and permit. Here also I am not going to define sequence number, so it will sequence number 20. Match IP address from list 4 and set tag 202 and router EIGRP as number 10, redistribute OSPF process 1 and call route map. Name is OSPF underscore what? Tag. Done. Now you can verify on router number 1. First of all, show IP route. Let me check that this router is receiving OSPF prefixes or not. Yes, router is receiving. Yes or no? AD value is 170 everywhere. So IP EIGRP topology. So here you can see tag number 202. That means this is prefixes of OSPF of team B. Yes or no? And if you want to check individual, you can check that also. Pipe section include tag is 201. So 201, it's not working. 202, it's not working. Tag, oh my god, not section over here. Tag is C. Because you know OS on OSPF loopback interface, if you are running loopback interface, it will install the prefixes with /32. So that's why output is different. Okay, so hope you are able to understand this thing. On OSPF by default network type is what, guys? Loopback. So loopback is also a type of network in OSPF. So IP OSPF database. So IP OSPF interface loopback 1. Here you can see network type is what? Loopback. So it will consider slash value what? 32. You have configured slash what? 24. But in the routing table of router 6 also you can see router 6 is here, guys. See, on router number 6 I am going to check these prefixes, these loopback prefixes. So IP root OSPF. So I am getting all 70 prefix. If you want to open any prefix in detail, what you can do, 70.1.1.0. So it is not in table. What is saying? It is not in table. So, but if I will define 70.1.1.1, you can see. That means router number 7 have advertised these prefixes with slash what? 30. Okay. So in the real time, these are my LAN network. Yes or no? So configuration redistribution will be same. So guys, these are, you know, advanced redistribution. Again, what we can do, we can filter prefixes as well while redistribution. Suppose this is team B and EIGRP domain now don't need to communicate with the user who belongs to team B of cell department. So why these router will install these prefixes, these two prefixes in routing table. So we can filter these two prefixes as well while redistribution over here. Okay, so those things maybe we will discuss in next video. Still video length is I think half an hour, 44 minutes. So that's all for today, guys. If you have learned something from this video, if we have discussed something new in this video that you was don't know earlier, and now you are able to understand, please hit on like button, guys. If you want this type of video, please subscribe this channel, please click on bell icon. We will meet soon in next video. Till then, stay safe, guys. Bye bye. See you in next